Earth's magnetism. How does the Earth behave as a magnet, and what are the things which are related to this concept? The first thing is just a brief history. In 1600, a person by the name William Gilbert, he was probably a French person, so he wrote a book called as The Magnet. That was the title of the book. In that, he first mentioned that the Earth is a magnet. Before that, it was only known that the magnet, the bar magnet or the magnetic needle, if they are suspended, it is going to come to rest in the north-south direction position. But why it is going to be like that? It was only a guesswork. It was only when this person, he gave an idea that the Earth behaves as a magnet. That is why all the magnets on the surface of the Earth, when we suspend them, they will come to rest in the north-south position. So it was only a proposal. There was no scientific proof of this thing, no mathematical proof of this thing. It was just a prediction. Later on, another person, Professor Blackett, he did some research and suggested that there is a magnetic field that exists with the Earth that was responsible, that was due to the rotation of the Earth. He suggested that the rotation of the Earth is responsible for the magnetic field which was mentioned in this book. So those two people laid the foundation, and much later it was realized when people started digging out, when they started studying the lava, how the lava behaves and what are the metals present inside the lava, we realized that the Earth has the magnetism because of the molten lava which is present inside the core of the Earth. What is Earth? Earth is a spherical planet. It is more like an oval shape. So now when we see the Earth, we think of Earth as a sphere, and on that sphere, just recall your high school social studies, that is called as equator. The line which passes through the center of the Earth, we call it as equator. Then we have our north pole on the top, we have the south pole on the top, then there are some more lines. So somewhere here we are going to have a Tropic of Cancer, and similarly in the lower part we are having these kind of lines, and somewhere here we are going to have Tropic of Capricorn. So there is an Arctic circle, there is an Antarctic circle. So these are the things, these are geographical things you are studying in your social science. So these things, and let us assume that there is an axis which passes between the two poles, and the Earth rotates on this axis. This is our basic. This we have already studied in high school. So rotation is always from the west towards the east. That is why we see the sun rising from the east and setting in the west. So that is the concept. But the Earth in reality is not in this way. So what is the Earth? How the Earth is there? Instead of this line, which we suppose the axis of the Earth, it is not exactly vertical. Instead, it is slightly tilted. So this is the actual axis of the Earth. So if this line is tilted, so what we are going to see here is the latitudes, whatever the lines are drawn there, they are going to be like this. I hope you are able to imagine this. So whatever the lines I had shown there, they are going to appear like this, and this is the equator. Next. And when we see this is the tilt of the Earth, where is this is going to be my north pole, this is going to be my south pole, and that is going to be the equator. Now above that, if we put these vertical lines, these are called as longitudes. I don't know exactly what is, I think this is called as Akshanta Guru, and these are called as Rekhanta Guru. I don't remember exactly. So the horizontal lines are latitudes, the vertical lines are longitudes, or they are also called as meridians. Now coming to this figure, this north pole and south pole, we assume it to be vertical, but in reality it is slightly tilted, and this tilt is responsible for the seasons. One side is winter, one side is summer. So that tilt is responsible for that one. Now, again, if I continue with that diagram, we will be having the longitudes here. And this Earth is rotating like this. Now, whatever I have shown with the blue colored chalk, they are for the geographical things. Now, let's go into the magnetic things. Now, imagine. Everything from now on till next 5 minutes is going to be your imagination. You need to be very focused. Imagine water, earthen water, inside that there is water, and you have held it from the top and bottom, and you have some mechanism which is rotating that one. That pot is rotating. When that pot is rotating like this, the water inside that pot will also rotate with the pot. So there is a movement in the water that is going to create a convection current. The movement of water inside that pot, due to the circular movement of that pot, it is going to create a circular motion of water that is called as the convection current. Now, the same thing if you imagine about the Earth. What is this? This is an Earth. This is the crust of the Earth. Crust on the outer surface of the Earth. What is the other? There is a core of the Earth. Inside there is a core. What is present inside the core? There is molten lava. we have molten lava inside. So when the earth is rotating like this, when the earth rotates, the molten lava also rotates along with the earth, just like I said for the pot. The water moves inside the pot, the lava moves inside the earth. Now what does this lava consist of? The major contents of that lava are iron and nickel. So iron and nickel in the molten state are the main materials present inside that one. Then when that lava moves, these atoms of iron and nickel also move. And because it is a very hot lava, it is at a very high temperature, that is going to those atoms will be broken into ions. And when those atoms of iron and nickel, they have become ions, that means they possess the charge. And when those charges are present inside the lava is in motion, it is rotating, and that rotation of that lava is going to produce a magnetic field. Because that is the concept of the generation of magnetic field, that is the moving charges produce magnetic field. So when this is rotating like this, it is going to be producing something like this. If this is the rotation, I have to show the magnetic field like this. So there will be magnetic field lines coming out from the top. So this side is going to appear like a North Pole. Then what happens when the lines come out from the top? What they have? They have to cover this earth and they will enter the water. Now this is our assumption. But again, going back to the pot. The pot is rotating, there is water inside, the pot is rotating, the water inside is rotating. Now, if the pot, instead of keeping the pot like this, if I turn it like this right now. Now, if the water rotates, if the pot rotates, the water also rotates. But whether that water will rotate with the same axis as the pot, that is the question. Till the time everything was vertical, The earth was rotating with an axis, the water inside, that also was rotating with the same axis. But when our earth has been tilted and the axis move either way, there will be a change in the direction of rotation. And that rotation, it is going to remain inside the core of the earth, but that axis of that rotation, it may be going like this or it may be going like this. So it is going to take place over a period of approximately 1200 years. In 1200 years, if the axis keep direct, first that axis of, I'm not talking about the axis of the earth, I'm talking about the axis of rotation of lava. So if it was initially like this, it will tilt like this along the line of the axis of the earth. Then after again 1200 years, it will go like this. Again after 1200 years like this. So it goes on for, like, we know that earth is nearly about 4.5 billion years old. That was from the era of the dinosaurs. So that is the situation happening here. That axis, when it is tilted, let us say right now, that axis is like this. This is the axis of rotation of lava. I hope you are able to see this reddish colored line. So if this is the axis of rotation of lava, here I am going to get another North Pole, and here I am going to get another South Pole. Now, how to identify which one is which one? Which one is the North Pole of Earth and which one is the North Pole of the rotation of Earth? That is the rotation of lava. So initially, when I had shown you these blue lines, all the things were referring to the Earth. So I am going to call it as G and P. That is the geographical North Pole. That is the actual location of the North Pole. That is where the Earth rotates. So if you stand on that North Pole, you are going to only circulate around yourself. You are not going to move anywhere. Same thing is true with the South Pole, which I have written with this blue color. Next thing, this line which I have drawn, this is called as MNP, that is MSP, that is the magnetic North Pole and magnetic South Pole. Now what happens with these lines which I have shown here? Where those lines are going to come out? They will be coming out from this North Pole, that is the magnetic North Pole, and they will cover the Earth, and they will go back in, and they will come out like this, and they will go back in like this. So in this way, the Earth's magnetic field lines are going to be existing around the Earth. So that is how the Earth behaves as a magnet. Now, you may be asking for further details. There is an axis here, which is called as the geographical axis. There is a blue line here. Then there is a orange colored line. There will be some angle between this. And this angle will be approximately half of the tilt of the Earth. What is the tilt of the Earth? How much the Earth has been tilted? 23.5 degrees. 23.5 degrees. If the equator was supposed to be like this, it will be tilted by 23.5 degrees. So that is the value of the tilt. And this tilt of the magnetic field, it is approximately 11.3 degrees. So the actual North Pole is not the North Pole. The actual South Pole is not the South Pole. Instead, they are shifted by some distance. The distance yesterday. The North Pole, the geographical North Pole, and the magnetic North Pole, they are separated by an approximate distance of 2000 kilometers. Similarly, the geographic South Pole and the magnetic South Pole, they are separated by a distance of, again, nearly 2000 kilometers. So where it is located? According to whatever we see in geography, the North Pole is in the center of Arctic Ocean. That is the geographic North Pole, whereas this magnetic North Pole is somewhere in the northern region of Canada. So if you have seen the Earth as a globe, you may be able to locate the Canada, and in that, somewhere you are going to find that, and the location is also given. The location, if you are able to see the latitudes and longitudes, the numbers here in India, you can find it there. The location of the North Pole is there, that is, this is the location of magnetic North Pole. It is 79.74 degree north, that is latitude, and 71.8 degree west longitude. So I hope you know how to read the maps using the latitudes and longitudes. For the magnetic South Pole, again the latitude will be same, 79.74, but in this case it will be not north, it will be south, and the longitude is 108.22 degree east. So that is the location, that is in our period. That means our period is like a very long period, 1200 years has to pass before that location changes. So it is right now, according to your book that is given in NCERT, these are the locations of the magnetic North Pole and magnetic South Pole. According to geography, the North Pole should be at 90, the South Pole should also be at 90 degree latitude. And also, this east and west should not be applicable because it is at the tip, and at the tip of north tip and at the south tip. So I hope the concept is clear. The earth is like a pot. Inside the pot there is water, there is a liquid. When the earth rotates, the liquid also rotates. And when we tilt that earth, when that pot is tilted, the liquid inside that pot will also get tilted. There will be one axis of rotation of that pot that is going to give us the axis of rotation of the earth, and there is one more axis around which the liquid inside that pot is going to rotate. The same thing applies for the lava. It is rotating with a different axis, and that different axis is going to shift the North Pole away from the geographic North Pole. So the geographic North Pole will be at some location, the magnetic North Pole will get a different location. So just like the pot, there will be two different axes. One is the axis of rotation of the pot, and one is the axis of rotation of the liquid inside that one. Similarly, the earth has one axis of rotation of the actual core, the crust of the earth, that is the top layer of the earth, and inside the core, that is the lava, it is also rotating, but the axis is slightly at a different angle. So that is about how the source of magnetic field is there. Now comes the big question. The big question here is, if you take a compass in your hand, compass means not your geometry box, I'm talking the compass which gives the direction. So if you take a compass in your hand and if you look at the needle which is pointing, according to us it is pointing towards the north, but in reality it is not pointing towards the geographic north, instead it is pointing towards the magnetic north. Similarly, if you look at the south end of that needle, it is not pointing at the geographical South Pole, instead it is pointing at the magnetic South Pole. So that is the difference. From here, staying in India or staying in the southern part of India, it doesn't affect us because that difference of angle between the geographic and the magnetic North Poles is very negligible. It is like 0.5 degrees or 0.4 degrees approximately from our location. So it doesn't matter whether we are looking at the geographic north or whether we are looking at the magnetic north. It is going to be almost the same. Half degree difference will not count, at least from here, from our location, that is from South India. Then, instead of here, if we go somewhere near to that place, like somewhere if we go to London or somewhere in England, somewhere in Germany, there if you look, you are going to find the North Pole and the the North Pole and the magnetic North Pole, they are at a big angle. It will be like 20 degree apart or 30 degree apart. It will be like that. So, in our place, the angle is very small, it is negligible. That is the angle between the magnetic axis and the geographical axis. So, I hope you are clear with the concept of source of Earth's magnetism. Let us say I want to look, where is my North Pole? Let us say this is the Earth. It is somewhere here, our India is here, and here in the southern part of India. And this is the geographical North Pole, and this we know, Canada is slightly left side of, from where we stand, Canada appears to be slightly on the left hand side of the North Pole. So this is the geographical North Pole, and this is the magnetic North Pole. So if I look, this is the geographical North Pole, this is the magnetic North Pole. So there will be a small angle here. That angle is going to be defined as a term. It is called as declination. It is declination, D-E-C-L-I-N-A-T-I-O-N. That is magnetic declination. Now, how to understand that? For that, I'm going to draw some more lines here. These are magnetic longitudes, and the blue ones are the geographic longitudes. What I'm going to see here is, let us say our location is somewhere like this. We are looking here somewhere to the Canada. The geographical North Pole, geographical North Pole here, magnetic North Pole is here. This will be clear here. So there will be some line passing here. There will be some geographic line passing, but the magnetic field lines will start from that position. So this is like this, and this is going to be like this. So some angle is going to appear between the geographic meridian and the magnetic meridian. What is magnetic declination? It is the angle between the geographic meridian and the magnetic meridian at a given place. So here, if I am standing in South India, it is going to be a very small angle. If I move slightly towards up, that is towards north, like if I go into like Delhi is in the northern part of India. If I go there, this angle, which here in the southern part of India is going to be a small one. But if I go here, if I see the magnetic angle there, it is going to be slightly bigger than what it is going to be here. So as we go towards the north, the declination is going to increase. And if I stand on the top of the geographical North Pole, we are supposed to be having it, we are standing on the top of the earth. But what if I take the compass out? It is going to point that North Pole is towards this side. So what is going to happen? I'm not standing on the magnetic North Pole, I'm standing on the geographical North Pole. Then, if I move ahead, like approximately 2000 kilometers, if I stand on the magnetic North Pole, then if I try to look at the compass, it is not going to give us any reading. Instead, the needle there, instead of the needle being like this, the needle is going to go like this. Because that is how the magnetic field lines are there. At the North Pole here, if I'm here, the needle is going to stand like this. If I go slightly northwards, the needle is going to be slightly bent towards the downside. And when we reach the top, that is the magnetic North Pole, at that position, the needle is going to be standing vertical. So, the angle between the geographical meridian and the magnetic meridian is called as declination. Next is going to be magnetic dip. Declination and inclination, they are not opposites of each other. They are two different terms. Again, they are totally two different terms. Dip sometimes can be referred as inclination. You're going to be getting clear with that meaning in a few minutes. So let us say this is the magnetic equator. This is the geographic equator, which I have shown with the blue color. So this is the magnetic equator. If I am standing on the top of this equator, the magnetic field lines are going to be exactly parallel to the Earth's surface. So there I am going to get exactly horizontal. The needle is going to stand exactly horizontal if I have hold a compass in my hand. But if I go towards the north side, that is somewhere our India is located, it is towards the northern hemisphere. So if I go there and if I go into there, the magnetic needle is going to be slightly tilted by a small angle. It is not going to be exactly horizontal. It is going to be, instead of horizontal, it is going to be slightly tilted downwards towards the north side, and it is going to be slightly raised from the south side. That angle, if we measure, if I take this as the surface of Earth, and if I measure this angle, there will be some angle, it will be very small, maybe 1 degree or maybe 2 degree, or even smaller than that one. That angle is called as magnetic dip, because the needle is trying to take a dip. That is one. Then further, if I go even further, like if I go to Russia is again somewhere near to the North Pole. If I go there and stand, the needle is going to be, because the lines are going into the Earth, the needle is going to be like this. Instead of the needle standing like this, the needle will be standing like this. It is going to be in a much bigger angle. If we go and stand exactly on the location in Canada where the North Pole is located, the needle is going to be not like this, the needle is going to be like this. It is going to show the North Pole is down, South Pole is up. What is happening? Because we are here. And it is going to show the North Pole is down and the South Pole is up, because the field lines are going to go to the south. It is going to just follow the magnetic field lines. So that angle, which is seen between the magnetic needle and the horizontal surface of Earth, is called as the magnetic dip. So there are two terms, one is the declination and one is the dip. Dip is usually referred with the theta and declination is usually referred with the delta, that is the small letter delta.